Okay, a little warm-up question before we begin another section on 4.4, right? So right now we've done 4.3, which is working with rational exponents. So 4.3, just a little warm-up question before we start 4.4. What we did here in 4.3 was we started to work with rational exponents. So the first thing we want to do when we work with a rational exponent is I always want you to try to see if you can make the number smaller. That's the radical on the bottom, right? So that radical on the bottom is a 3. I'll just zoom in a little there. Okay, so that's little 3 on the bottom there. So this 3, that means third root of 8. Third root of 8. I don't need you to rewrite it in radical form, but you're picturing third root of 8. What is the third root of 8? Third root of 8? 2, okay? And hopefully you're picturing that 2 pretty quick, right? If you've done all the homework, you should be going 2 times 2 times 2. So third root. So do this first. That is your first step. Okay, so that is your first step. Then after that, you're just going to write what's left over. So I did this part, and you're leaving the negative 2 alone. Okay, I want to see these steps this year. As you get more comfortable with it, you'll be skipping more steps, but not yet, not this year. Yeah. Not of everything, but 8, if you've done your homework, it should come up about 10 times in homework.
But on the homework, there's also one that was like the third root of like 120 or something.
Yeah, and again, you'll start to recognize some of them. So like 256, that one might be a little bit too big. That's when I would say, okay, that's when you can grab your calculator and try to break it down. So instead of doing a factor table, so what we used to teach was that you didn't do it on a calculator, you would do a factor table and break it down until you got groups of 4. So this one you can use your calculator and go, okay, I just want to cheat on this one and do a 4th root of 256. And remember, a lot of the universities now, so that's this little button here with the little X, will not let you use a calculator on first-year calculus. So if you do take it, and this is for general sciences, I mean, engineering I'm sure is way beyond, but for general sciences, they just gave up and they said, forget it, no calculators. They make the numbers small enough so you can do it, and so it's not a big deal, but you should be able to do small calculations like this. So 4th root of 256, if you're like, I do need some help, it is 4. Right? The backwards way is to go, what do I think? 4 to the power of 4 is 256. You know it's an even number, yep. I just pointed to it. This one here with the little X on the top. Get out your calculator. Do you have the same one as me? Yeah, so look on your calculator, get it out so you can see on there. Right, so it's the one above that little arrow up button, and you'll see there's a little X. Right, so you're going 4th, and then shift, and that you should see this little root button with the little X there. Okay, so that's 4th root of 256. So that would be maybe the only time that you would use your numbers, your calculator, right? So I gave you a big one where you're like, oh, I'm not sure if I remember that one. That would be it, right? But other than that, you shouldn't need your calculator. Okay, and that one is like, I'm not sure if it's 4, pretty sure, but that one you could do. The opposite way would be 4 to the power of 4, and you go, oh yeah, it is 256. Okay, so that would be the one occasion where I'd be like, yes. The option that we used to have when I said we would give you guys these sections without a calculator is that you would have to break it down to the factor tables, and you'd be like 256, and you go 2 times this and break it down. It takes a long time though. So I know it's 4. Right, so the first step is this one. So I make that 4, and I'm leaving the negative 1 alone. Okay, so that's the first step I want you to do for all of these, and I want you to show me that step. Again, once you get comfortable, some people are like, I do that in my head, and then I just start flipping it around. I do want to see it. Okay, so I want to see that step. Here, if you start to skip a little bit, so this is 1 over 2 squared, this is 1, you might go, you know what, can I square it all in one go? Yeah, right, so you're going to get comfortable with that, but I don't want you doing 2 steps in one. Okay, so if you kind of go, I went 1 over 4, that would be okay, right? Because I know you can kind of square that on one go. Okay, and then 1/4 plus 1/4 would be 2 over 4, which again, we know will be 1/2. Is that okay? So again, just trying to refresh your memory because it's just feel like it's been a little while since we did that. Okay, and then the second question I just made up. So again, forgive me if it's not a great question, but the second question I just made up here is, okay, is this one here. So we got 3 to the negative 7, 3 to the 9, 3 to the 6, 3 to the negative 5. So my first step for all of these is always, always, always see if you can use the laws first. So you want to see the laws of, exponents first. The laws are the laws where if it's multiplication, you add it. If it's division, you subtract. And if you have a power to power, you multiply. Right? So that's what I mean by laws. So I don't want you to this is straight calculating. Right? This is us just calculating it, calculate. But they were separated by pluses, so I couldn't combine it using any laws. Does that make sense, the difference here between these two questions? Right, so this one here, there was a plus in between, so I just started calculating each term by itself. This one here, it's all connected by multiplication and division, so yes, I can use the laws. The laws are for multiplication, division, and power of a power. Right, so if you see that scenario, you'd go, wait, these two, instead of grabbing, so if you go, wow, I don't know, does she expect me to know what 3 to the 9 is? No, I do not expect you to memorize 19,683. Okay, that means we're doing it wrong. If you reach for your calculator and you write 3 to the power of -7 and get, what's that mean? What's this mean here again?
Isn't it 10?
Scientific notation, and it means you're bringing it 10 to the -4, which means you're bringing this decimal 4 times to the left. Okay? So that is a very small number. Is this a realistic number that you're trying to calculate? How many decimal places should you copy? None, because it's wrong. What you're doing is wrong. You go, wait, she said I shouldn't need a calculator. So then why am I getting numbers like this? So this is a scenario where, so see the difference? This one's here, it's pluses. I just go ahead and calculate the bottom, keep going. This is multiplication, division, power of a power, which means these guys here, I can add them. And these guys here, I can also add those. So I'm going to add those together. And then I'm going to see if that works a bit better. So on the top here, I'm going to get 3 to the 2 when I add -7 plus the 9, right? And here I'm going to get 3 to the, oh, it's a 1. Do I write the 1? No, it's invisible. And now for here, between these two, I subtract, don't I? You don't have to show what I did in orange there. But 3, that is 3. 3 squared divided by 3 is 3. Did I need my calculator? No. So that's what I'm saying is that using the laws of exponents first by combining it when they have the same base, you might be able to simplify it so you don't even need to do a negative. I do not want you doing this. So not 1 over 3 to the 7, 3 to the 9, 1 over, no. Once you start seeing yourself doing this, you go, wait, that's a lot of 1 overs, and I've just created more fractions on a fraction. That's bad. So you're never doing this. What some people go, well, what I did instead is I started to move it. That's okay. That's okay. Some people go, I brought this down here. So this is or. So if you go, okay, still using the laws without doing straight calculation, I'm going to bring this below. So I go 3 to the 9 stays where it is. 3 to the -7 moves down to the bottom, yes, because negative moves down to the bottom. We started this before. 3 to the 6 stays where it is, but 3 to the -5 moves up here. And you go, wait, that's going to be different. Is it? When you add these two now and add these two now here, on the top I'm going to get 3 to the 14, and the bottom I'm going to get 3 to the 13. And when you subtract those, I get 3 again. So this is using, yes. This is using the laws, but you did shift it. I just don't want to see fraction on a fraction. That makes it way more difficult. So the only flipping you're doing is when it's going to make your question a bit easier by making it positive. Yes?
If you go to the first part of the question,
yes.
Yeah. How come you didn't multiply 3 and 3? Like, how come that's not...
Okay, you asked this before, right? So what we're remembering is at the base, this is what you do if you had 3 to the 3. The 1 plus the 1, you're adding it, it's 3 squared. This has a number. So you're not going to add the 1, because what you're trying to do is doing a 1 and a 1 plus doing the exponents. The exponent is -7. Does that make sense? It already has an exponent, so only do the exponents once. This is what you're thinking of this, right? 3 to the 1. If there was a 1. And again, look, if I had m and m, you know it's a 1 and a 1, so that would be m squared.
So just like think of the numbers as like...
The number is replacing the 1. So you're not going to do the number again. So again, look, I know, and a lot of people get this mixed up. So if I do this, right, that would just be m, you add them 2. You don't do another m squared on top of it because you're doing this separate than this. So once they have an exponent, that's all you do. You add these two, and then you leave the m as it is, right? You're trying to do an extra 1 on top of it by saying m times m is m squared, but you already have an exponent. Okay? So try to stop, yeah. All right? And that's a good question, right? Because that's a common thing is that why don't I double the m's? Because you already did the m's. The exponent of the m are these guys, not 1, right? Because you're thinking of this, right? The base has its own. Right? So once the base has a different exponent, then you just do that once and keep the base. So keep the base, and you added the exponent, so that keeps the m at the exponent. Okay, good? Any other questions? Okay, so that's just a little warm-up.